Hey everybody, it's your boy. What's going on? I don't even know what that was. Standard YouTube intro. Anyways, it's me, Jeremy, and this is iTech 360. Hope you're all doing well. Today we're going to be talking about environmental and life safety controls. And as usual, most of my information will be taken from the CISSP prep guide. So if you have that, please follow along. And let's get right into it. So, environmental and life safety controls are considered to be those elements of physical security controls that are required to sustain either the computer's operating environment or the personnel's operating environment. And usually, three areas that are a main point in environmental controls would be electrical power, fire detection and suppression, and heating, ventilation and air conditioning, or HVAC. And we're going to talk about some of those areas right now. First off, we're going to start off with electrical power. And within electrical systems, the lifeblood of a computer operation lies. And clean and steady power must and is required to maintain the proper work environment and to sustain data operations. And now there are many things that would threaten or that can threaten power systems, but the most common being noise, brownouts and humidity, and those are what we are going to talk about today. Noise in power systems refers to the presence of electrical radiation in the system that is unintentional and interferes with the transmission of clean power. And there are several types of noise, the most common being electromagnetic interference and radio frequency interference. AMI is noise that is caused by the generation of radiation due to the charge difference between three electrical wires, the hot, neutral and ground wires. And within AMI there are two common types generated by electrical systems. Common mode noise, which is noise from the radiation generated by the difference between the hot and ground wires, and transverse mode noise from the radiation generated by the difference between the hot and the neutral wires. RFI is generated, on the other hand, by the components of an electrical system, such as radiating electrical cables, fluorescent lighting, and electric space heaters. RFI can be so serious that not only interferes with computer operations, but it also can permanently damage sensitive components. RFI can degrade the performance of equipment or even prevent it from functioning. In some cases, RFI may also cause damage to digital and solid state equipment. And the actions that would usually be taken to be a solution for these problems would usually be power line conditioning, proper grounding of the system to the earth, cable shielding, and limiting exposure to magnets, fluorescent lights, electric motors, and space heaters. So brownouts. Unlike a sag, a brownout is a prolonged drop in supplied usable voltage that can do serious physical damage to a delicate electronic component. And for those who don't know what a sag is, it's basically a voltage dip. And so a voltage sag would be for like a second, whereas a brownout would usually be for a longer period of time, which, like I said, could cause some serious damage to your components or any component within the electrical system. Humidity. The ideal operating humidity range is defined as 40% to 60%. High humidity, which is defined as greater than 60%, can produce a problem by creating condensation on computer parts. And I think you could actually visualize that. High humidity also creates problems with the corrosion of electrical connections. A process similar to electroplating occurs, causing the silver particles to migrate from the connectors onto the copper circuits, thus impeding the electrical efficiency of the components. And corrosion actually messes with a lot of factors that make a component what it is and how usable it becomes or can be. And with a low humidity of less than 40%, it increases the static electricity damage potential. A static charge of 4000 volts is possible under normal humidity conditions on a hardwood or vinyl floor, and charges of 20,000 volts or more are possible under conditions of very low humidity with non-static free carpeting Although you cannot control the weather, you certainly can control your relative humidity level in the computer room through HVAC systems. Your HVAC system should maintain the proper level of relative humidity in the computer rooms. And now moving on to another main area of environmental control, we have fire detection and suppression. The successful detection and suppression of fire is an absolute necessity for the assurance of a safe and continuous operation of an information system. That being said, we need to be aware of the classes, combustibles, detectors, and suppression methods of fire safety. So first up, we have fire classes and combustibles. For rapid oxidation to occur, or as we know it, a fire, 3 elements must be present: oxygen, heat, and fuel. Each suppression medium affects a different element and is therefore better suited for different types of fires. For example, water suppresses the temperature required to sustain the fire. Soda acid suppresses the fuel supply of the fire. CO2 or carbon dioxide suppresses the oxygen supply required to sustain the fire. And halon. Halon is a liquefied compressed gas that stops the spread of a fire by chemically disrupting combustion. The fire detectors. Those annoying things that beep anytime there's a fire, but you have to listen. Fire detectors respond to heat, flame, or smoke to detect thermal combustion or its byproducts. Different types of detectors have various properties, just like the different types of suppression methods, and each of these use their different properties of a fire to raise an alarm. So there are 4 different types of detectors that I'm going to mention here, which are heat sensing, flame actuated, smoke actuated, and automatic dial-up fire alarms. Most of these are pretty much self-explanatory, but I'm going to just give you a quick definition of each one of them. So the heat sensing detector responds when the convected thermal energy of a fire increases the temperature of a heat sensitive element within the detector. Flame actuated detectors sense either the infrared energy of a flame or the pulsation of the flame and have a very rapid response time. Smoke actuated, which actually are useful in systems where early warning is a must, uses photoelectric devices which are triggered by the variation in the light hitting the photoelectric cell as a result of the smoke condition. And now the automatic dial-up fire alarm is not a detector in itself, but is used with either one of the previous detectors mentioned, which dials the local fire or police stations and plays a pre-recorded message when a fire is detected. And moving along, we have fire extinguishing systems, and these come in 2 flavors: water sprinkler systems and gas discharge systems. Water sprinkler systems come in 4 variations: wet pipe, dry pipe, deluge, and pre-action. A wet pipe sprinkler system always contains water in them, and in the event that heat rises to a certain heat, a fusible link melts in the nozzle and opens a valve, allowing water to flow. The dry pipe, however, has no water standing in the pipe. It is held back by a valve. But in the event of a heat rise, which is similar to the wet pipe, the valve opens and air is blown out of the pipe and the water flows. A deluge system is a type of dry pipe, but the volume of water discharged is much larger. Therefore, it is more efficient than the dry pipe. And unlike a sprinkler head, the system is designed to deliver a large amount of water to an area quickly. It is not considered appropriate for computer equipment, however, due to the time required to get back online after an incident. As of right now, the pre-action water system is the most recommended for a computer room. It combines both dry and wet pipe systems by first releasing the water into the pipes when heat is detected, then releasing the water flow when the link in the nozzle melts, just like a wet pipe. Now on to gas discharge systems. They, however, employ a pressurized inert gas and are usually installed under the computer room raised floor. The fire detection system typically activates the gas discharge system to quickly smother the fire either under the floor, in the cable areas, or throughout the room. And usually CO2 or halon is used in these type of systems. And these two are both suppression mediums that are commonly used. CO2 is a colorless and odorless gas which is very effective in fire suppression due to the fact that it quickly removes any oxygen that can be used to sustain the fire. And there was once a time that halon was considered the perfect fire suppression method in computer operation centers due to the fact that it is not harmful to the equipment, mixes thoroughly with the air, and spreads extremely fast. The benefits of using halons are that they do not leave liquid or solid residues when discharged. Therefore, they are preferred for sensitive areas such as computer rooms and data storage areas. And the reason I said that it was once considered to be perfect is that there are many issues that arose, but one that mainly arose was that it could not be breathed safely in concentrations greater than 10%. And when there's a fire, there's usually some kind of fallout with the environment, whether it be contamination or damage resulted from the fire or the suppression of the fire. And it can be very dangerous to the computer systems by depositing conductive particles on the components. Smoke, heat, water, or any of the suppression mediums mentioned earlier would be considered types of fire contaminants. HVAC. Now HVAC we talked about before and is also referred to as HVAC-R with the addition of refrigeration, and these systems can be quite complex in modern buildings and the focal point for environmental controls. An IT manager needs to know who is responsible for HVAC, and clear escalation steps need to be defined well in advance of an environment-threatening incident. The same department is often responsible for fire, water, and other disaster response, all of which impact the availability of the computer systems. And now a HVAC system is not only important for your computers and your computer rooms or any equipment, but it's also important for you, the worker, because the fact remains that fresh air is good for the body, and in commercial buildings it helps to improve productivity. Okay guys, that's it from me today. Hope you all enjoyed, hope you all learned something. Please leave your comments in the comment section below. If you're new to the channel, please subscribe. Hope you're all doing well, and see you next time.